All right, so we're gonna do 7.2, which is the this method, and we'll also do the washer, which is just an extension of this. Let me see here. And zoom in a bit. Okay. 7.2. Volume. So in the last section we did the area, so now we're going to do volume. So it'll be very similar, except we're going to rotate that little section. So remember how we had a section between two curves. So imagine spinning that and creating a solid. That's where we're going to go. That's where we're headed. Washer, like the little donuts. Okay, let me write the theory first, and we'll get started on some examples. So the disk method to find the volume of a solid of revolution with the disk method. Use one of the formulas below. But they were muted for a second. One of the formulas below. Okay, so it all depends on the orientation of the region and how you slice the graph. So let me give you both situations. Remember how I kept saying 7.1 we had the vertical slice, right? It was like top minus bottom. So if we have that same situation, then we use this formula, the horizontal axis. Revolution. Okay. So V is equal to pi times the integral from A to B of R of X squared dx. Let me draw you a picture of what that looks like. Let's say you have some point A and point B. You have a question, Hino? Or no?
I missed the last station, so I don't know where you start from.
You missed what? I'm sorry.
I missed the last class, so I don't know where you guys are starting from. Like the last station.
Yeah, we're starting with 7.2. Last class was 7.1. It was the beginning of chapter 7.
Okay.
So it was the area between curves.
Okay.
Let me switch that to speakers so I can hear you better. There we go. That's better. Okay, so I need to draw this picture. So let's say you have a region like this, right? And you want to know what is this area? Okay. So as you can see, there's the top function minus the bottom. Let's say it's bounded below by the x-axis. So when you see this, you need to understand that I need to slice horizontally, which means it's going to be dx. That's why it's dx. It's this type of scenario. Okay. If I'm slicing up and down, then that means I have to rotate, or that means that the axis of rotation is going to be horizontal. So it's always perpendicular to the slice. So if it's slicing up and down, in order to get dx, the rotation will always be this way. So if the question tells you I'm rotating horizontally or on some axis up or down, then the slice needs to be this way in order to use disk. Now, if the slice is this way, then I have to use a different formula. Right, so it's this one. And we'll go through it in a second. We'll do a bunch of examples. Vertical axis of revolution. So when using this method, it's always perpendicular. The rotational axis has to be. And if you can't make it happen, then you need to use a different method, which we'll talk about in 7.3. So the volume is equal to pi times the integral. We'll use c to d this time. Pi is the rotational piece. That's what I say. It's like I'm taking this section and I'm spinning it 180 degrees, creating a solid. The picture just going around and around in 3D. It will create like a cone, right? Like a little weird ball. Excuse me. Our y is going to be dy. So this type of scenario looks more like this. So this is my d right here and my c. Let's say that the graph is going this way. And I have this region that I'm rotating vertically. So if I'm slicing this way, then I have to have dy, right? I'm sure you saw those problems in 7.1, right? When you had to solve for y and it was a different direction, right? So when that happens, the rotation has to be on the y. Okay. Let me write some theory for you to explain all this later, in case you forget. Space, I'll wait a bit. You guys still on this page? the height of the rectangle where I keep calling it the slice, right? Non-mathematical terms. Are perpendicular to the axis of rotation. This is for this method, right? Trying to summarize this notes. Shorten them up a little bit. The entire region touches the line or axis of rotation. Because if it doesn't, then you're going to have a hole when you do the rotation. If it's away from the edge, you start spinning it, you're going to have a donut, which is why we need a washer. So this is assuming, like we saw in these drawings over here. See, this is the rotation axis, and I'm right on top of it. I'm spinning around that axis. But let's say I spin it away from the axis. Let's say I move this, I shifted this graph up here, and then started spinning. It would have a hole. Do you see that? I mean, it's hard to visualize. I'll show you in a minute. Let's write down the instructions first. And a line or axis of rotation in cases where the region does not touch the axis of rotation, a hole will be formed. During the rotation. Yeah, it'll make more sense when we do an example. I'll try to find a visual for you too. Just a moment. So to deal with the hole, let me try to show you what I'm trying to say here. Let's say I'm rotating over here, right? But my graph, my region, right, is up here. So if I spin this around, do you see that there's a gap? You can pretend it's like leaving a shadow, right?
Well, it has to be on the zero, right? On the right?
So it's on the line on this one, right? That's where it starts. That's where the
Yeah, let's say this is one. Right? So if it's closed off right here, but it's not on the rotational axis, it's floating away from it, there will be a gap. So that's the hole that they're talking about. So you just subtract this chunk in order to get the volume. If I'm right on there, like this example, I get a solid bowl with no holes. Okay, that's the difference between disc and washer. So if we're disc, we're good. It needs to be right on there. That's what we're saying right here. But when it's not, we need this formula. V is equal to pi from A to B R of X squared minus little r of X squared. Dx. Let me see if I can find a drawing for you. Somewhere.
What is open? Those terms, these colors, you know?
I mean, they're doing construction on libraries. So I don't know if they're open. Maybe I would check. I know the cafeteria is closed. Yeah, there's not many classes that go till 10. Let's see.
Choose a favorite as a school.
Kind of. A lot of our population is older, so they have jobs. So I figure this would be a good time to help people take a class after their work. And I'm not a morning person. So that's why I chose it. Let's do an example, try to make sense of this. Find the volume. Of the solid formed by revolving the region bounded by f of x equal to sine x and the x-axis. When they say about, they mean rotated about. So I'm going to go ahead and say that rotated about the x-axis. So just like the last section, we had to graph what they're talking about first. So let's graph sine. Actually, it's square root of sine. Right. So where is sine 0? You guys remember? Yeah, which value, which angle? Sine 0. Right, and at 0, it's 0, right? At pi, it's 0. Where's a 1? We'll change your pre-calc grades. Huh? Just kidding. Yeah, pi 2 or 90, right? So they said the graph bounded by the x-axis and the square root of sine. We could plot more points, but you know it's going to keep repeating itself. But we're not allowed to use negative values. So I'm going to stop here on this graph. So let's see. So you see why we must choose a vertical slice. If I choose horizontal, I'm going to hit the same graph 2 times. And you can't do that. It needs to be the top of the region, bottom of the region. If the region was oriented differently, and you would hit the right side and the left side without repeating, then you could use either or. But here you can only use vertical slice. So the top of the region where my rectangle goes, bottom. This is my delta x. So the slice determines the technique you're going to use. But since they already told me, I don't have to worry about any of that, at least not yet. They told me they're rotating about the x-axis, right? But the requirement of the disk method is that the slice is perpendicular to rotation. So they can't be going the same direction. If they're going the same direction, I need to use a different method. But these questions are set up to only do disk right now, so don't worry about that. So the formula says the volume will be pi times the integral r squared. So our radius is going to be the top function minus the bottom. So just like the last section, this is my radius or the region. Okay, so if it was a different function on the bottom, then you would put that function.
Which we use in vertical revolution.
Yeah, we're doing the horizontal. So squaring a square root, that's going to be simple, right? What are the bounds of integration, though? 0 to pi. Because we're doing dx, so we look at the x. What is the integral of sine? Positive or negative? So negative pi cosine from 0 to pi. Which will be negative pi cosine of pi minus cos. I'm going to put a parentheses to save space. Cosine of 0. So cosine of pi is -1, right? Cosine of 0 is 1. So this will be negative pi times -2, just 2 pi. Any questions about the setup for the integral?
What happened to that square?
Oh, square root.
Oh,
So the hard part is setting it up, figuring out what the slice goes, and eventually I'm not going to tell you which method to use. You can have 3 or 4 methods, and you need to figure it out based on the slice. Okay, so since I was forced to slice up and down, that determined the rotation must be this way, which tells me to use disc. Remember, that was a requirement for disc. It said the slice must be perpendicular to the rotational axis. Let's go on this page. No rush. But always check there's a gap. That way you know to switch to the washer, which is just an extension of disc. It's really the same thing. You're just kind of removing that extra piece. If you don't subtract it, you're leaving the solid. And that's not true. There's supposed to be a hole. You subtract that chunk. Okay, let's do another one and then we'll switch to the washer type. A lot of pages. Or the dot lines. Example 2. Find the volume of the solid formed by revolving the region bounded by the graphs, or just by this following here, by f of x equal to 2 minus x squared and g of x equal to 1 rotated on y equal to 1. So now I'm rotating, I'm no longer right on the axis or x or y axis. So we need to decide, is this a disc or a washer problem? So let's graph it to verify first, because it's not all pros at graphing, so maybe you can't see it. So this is 2 minus x squared is just a parabola facing down, right? Shift it up 2. So if I graph this guy here, let's say 2 is up here. What's the square root of 2? Is that 1.7? Yeah. 1.4. Okay, so let's say 1's right here. So 1.4 is about there. So the prow is going to hit here, here. Although that doesn't matter now that I think about it. Because it said there's a second part, right? Bounded by this parabola and bounded by g of x equal to 1. So if 1's right here, then I just need these points. So you can use decimals to find them, or you can use your algebra. remember we said to find intersecting points, you set both functions equal to each other and solve for x. So intersecting points would be 2 minus x squared equal to 1. Set it to 0. I'm going to move everything to the left. Minus 2 plus x squared. Factor this guy, and that'll be x plus 1, x minus 1. So it looks like I almost had it. 1's right here. Right? The intersecting points. Which will help us because we need to figure out the bounds. That's the only reason I did that, because the region is right here. Let me see if my computer will let me do Desmos. Freezing up earlier. Yeah. I think we used to every Wednesday have they prepare special meals. You can buy tickets. Really good food. I don't know if they still do that since COVID. It's a really cool culinary thing school here. Okay. Where is the share button? Yeah, a lot of issues right here. There we go. Finally, geez. I feel like I'm using AOL or something. All right, so first function is equal to 2 minus x squared. G of x is equal to 1. So that's what we drew earlier. So there's my intersecting points. So I'm going to integrate from -1 to 1. Right? And we found those using algebra by setting both of these functions equal to each other. Right? So we didn't need Desmos, but we can still check it out if you want. So where did it say we were rotating on? So we're rotating right here, right? That's 1 equal to 1. 2 is right here. That's 1. 1. This is 1, 1, 1, -1, 1. So is this a disk or washer problem? Why? Yeah, we're rotating right here, right? So there will be no hole. If we were rotating over here, there would be, right? You gotta see like where exactly does the edge end and where do we rotate? So it ends here, but we're rotating on that edge because it's a y equal to 1 is the same as g equal to 1. So this is a disk problem. It'll be -1 to 1 pi times top is going to be 2 minus x squared, right? Minus the bottom. What's the bottom? Bottom function of the region. At the top is a parabola. The bottom is this line. What is that line as a function?
Y equals 1.
Yeah, it's the 1, right? So we have to put that 1 right. See how that changed depending on where it's at. For a while, it's been -0. pay close attention. At this point, we just square it and start doing integrals. Setup is the hardest part. Is there any question on the setup? So at this point, it's just integrating, and I believe you can integrate this no problem, right? This will be 2 minus 1 is 1. So that's really this guy here. Which will give us it will give us 1 minus 2x squared plus x to the 4th. All right, now let's integrate term by term. The phi is just in the way, so we can just pull it out in front. So the integral will be integral of 1 is just an x. Integral of this guy is add 1 power, divide by that same thing. Add 1 power, divide by that same thing. And let's skip this step here. The answer will be any questions on the setup or the integral step from here to here? Do another one. One moment. Guys, go on that page. Okay, example 3. Find the volume of the solid form by rotating or by revolving the region bound by the following. I'll use y this time for no reason. But the x-axis. Okay, so we know this is a, we should know what these look like. They're the standard parent functions. But the square root looks like like this. Keeps on going. Let's say, let's say one's about. Square root of 1 is 1. Now, 1 squared is also 1. And this function keeps going. Technically in both directions, but doesn't look like I need this left side. Here's my region. They said about the x-axis, right? So my slice is from here to the axis of rotation. Is this going to be a washer or a disc? Is there a hole or no?
Yes.
Because I'm rotating this way, right? Yeah, looks like yeah, it looks like there's a gap here, so we have to do disc. No, sorry, washer, sorry. So So this is going to be from 0 to 1, right? So R of X, big radius minus the little radius. Dx. Give me 1 second. Need a definition here. There it is, okay. That's what I thought. So I need to make sure I label capital R and little r. So the distance from the top of the slice all the way to the rotational axis. This distance here is capital R. And then this distance here is R.
Why that? Oh,
Not that point specifically, just the bottom edge, all the way down, all the way. So R is a function. So R is, and the distance of R will change depending on what point you choose. So R is the radius from here, this at bottom edge to the rotational axis. Capital R is in the top to the rotational axis. So what is that top function? Right, the top is square root, right? Minus what's at the bottom? What is the axis of rotation? 0. Minus the small radius. What's the small one going to be? So, x squared minus the bottom, right? Okay. So square root squared, that's pretty easy, right? That's just x minus this squared will be x to the 4th. So that's just dx. So integrate that guy from 0 to 1 and we get x squared over 2 minus x to the 5th over 5 from 0 to 1. Which will be pi times 1/2 minus 1/5 times 0. So that's about what? That's 3 pi tenths, is that right? Yeah. Any questions on the setup for disk? So whenever you have a hole, you just subtract the hole. That's why it's right here, the inner part. Because you're taking that part off. Because if you only do this, it's assuming it's completely solid. That's pretty much it for disk and washer. Do you have any questions on disk and washer?
Another example for this, for this.
Yeah, let's do this. Set aside. Find the volume of the solid form by revolving the region shown. About the y-axis. Just to make it easy, I'm going to give you the function. It's something like this. It's a really bad drawing, but whatever. So negative y squared plus 5y. So if we're rotating about the y-axis, rotating this way. That's telling us that we have to, if we're going to use this, we need to slice perpendicular to the rotation, right? So I need to slice this way. I have no choice. But if I slice that way, that means I have dy, which means I have to have a y function. If it's not in terms of x, if it's not solved for x, you need to solve yourself for x. Like it might be, scrambled or something. Or it might be y equal to. Okay, so what's the right minus the left, right? What is capital R? And do we have a hole? And we're spinning this way. So, and we're right on the rotation, right?
Yes,
We're right on there. There's no hole. We're spinning away from the axis of rotation. There is a hole. So we have the right side, which is this, minus 0. No hole. So since I'm doing dy, I need to have these points. So I went ahead and gave them to you, 1 to 5. So we just integrate like normal, and we're good. Nothing crazy about this. So that'll be negative y cubed over 3 plus 5y squared over 2 from 1 to 5. Oh, that's not true. Forgot the square. That's fake math right there. Okay. So if I square this guy here, that'll give me a y to the 4th plus 10y no minus. Yeah. 25y. Okay. Or you can do the FOIL or whatever you want. So at this point, just term by term integration. We're done. So y fifth over 5 minus 10y cubed over 3 plus 25y cubed over 3 from 1 to 5. Plug in all those numbers and eventually some ugly garbage. But I did forget something. Do you see what I forgot? I. You always have the pi, that's what causes the revolution, right? So at the end of the day, we're going to have about, let me see the answer. Yes, wrote this earlier. 1472 pi over 15. It's a beautiful number. What's the volume? Okay. So what I recommend when you start these is graph them first, figure out where the region's at, and then see if there's a gap or not. You can choose disk or washer. And you also, if they tell you where you're revolving, then that will determine where the axis is going to be your slice, I should say. So the slice will determine if it's dy or dx. So just pay attention. Okay, where am I rotating? About the y. They say y, then they say y. Then I need to do parallel. If they say rotate about the x, then I'm going to be rotating perpendicular to that, right? Opposite. Okay. And any questions on 7.2?
The horizontal axis of revolution is the washer.
The what?
The horizontal axis of revolution is the washer. And the vertical or the formula sometimes.
Those two formulas is for disk. I mean, it's the same for both, disk or washer. The only thing is you add the subtraction to remove the hole. So the two formulas are dictated by where you're revolving. So if you're revolving on if you're revolving horizontally, then you must choose the vertical slice, the vertical formula. If you're rotating this way, then you have to choose the horizontal formula. The washer, the only difference in washer is you have a minus, you might subtract a little part. Only it's the same thing, you just have an extra piece. But the rules are the same. Okay.
And the second part of the integration, would the percent be a cube? And then on the last part, would it be like to the fourth?
Yeah, that's right. So that'll be cube. Yeah, I think we both said cube, man. I forgot about it.
That was kind of like,
What happened there? Okay. Cubed for 4. We still have some time. Go ahead and do the 7-3. This is the shell method. This is a little harder than the other two methods. Was zoomed in better or this better? Huh? No, I meant the camera. Zoomed in or zoomed out? Yeah.
You say 7-3?
7.3. Volume, still volume. This would be the shell method. Okay. To find the volume of a solid of revolution with the shell method, use one of these formulas. Well, no, before I get to the formulas, I need to mention something. Note, in the book they call this rho, not P. So rho is the difference. The Greek letter, I just can't draw very well. That's rho. Greek letter rho. Looks like a P kind of. I just can't draw it very good. This wasn't so laggy, I'd show you on the screen. It kind of looks like a P a little bit, but it's not a P. Yeah, see if I can share it. My computer drive me nuts. I might just hook up my laptop instead. Come on. There it is. So this is rho that I'm trying to write down. So this is the difference between the region of the axis of revolution difference between the region and the axis, line or axis, depending, of revolution.
The difference between what?
What's up?
What did you say? The difference between the dash.
Oh, the difference between the region
Oh, okay.
and the axis of revolution. So like the little shaded section. So it's gonna have a horizontal and vertical just like before. So it's this scenario here. It's kind of the opposite, sort of, of the disk.
Are we gonna add now?
Right? What do you mean?
Wasn't sure it was all. And that was a working of it.
Well, the setup will be the opposite. So if I'm slicing this way, and I have dy, then I have to be rotating parallel. The other one was perpendicular. So now we're going to have dy if I'm slicing, if I'm rotating that way. So basically, if they tell you you're rotating horizontally, you are forced to use dy unless you switch to disk or washer. You have no choice. So if you want to use shell method, you're going to have to do dy. Sometimes you can do any method you want. You just have to set it up. Some methods will be super easy and some will be very complicated. So sometimes you need to choose the correct method. We'll get to that later. Here's the formula. V is equal to 2 pi integral from C to D of rho of y times h of y. So h is the height of the slice. So this right here is h of y. Oh man, it's smeared it. Make some space here, make it prettier. So the height of the rectangle is h. Rho is the distance, right? We said between the region and the axis of revolution. Region, the axis. So from here to here. This this distance here is rho. So anywhere on the region until the axis is rho y. The height of the rectangle is h dy. That makes sense? In this case, P of y will be defined. Let me double check here. Yeah, that's right. Okay. Looking at the book, it didn't make sense for a second. Top minus bottom. Right. Top minus bottom. Which is basically some y distance minus a. So rho of y is equal to this. this is the case if the region is above the axis of rotation,
Is it what? Bound?
above. It's equal to a minus y if the line is below. If the line slash axis, right, of revolution is revolution is double check this idea. Oh yeah, yeah, both region. It's just the opposite. Sorry, I'm getting tired. Region. There we go. This will help kind of get it. When we start doing the setup, this will help you later on. I know probably doesn't make sense just yet, but we'll get there. So it's y minus a if the region is above the rotational axis. A minus y if the region is I'm being dyslexic. If the region is above region above rotational axis. Yeah, the way to phrase it is confusing. It's confusing myself. Because what I'm saying is the region is above the rotation. Over here, I'm saying the rotation is above the region. So they're opposite. But the phrasing, it sounds strange. Sorry about that. Do you see what I'm saying though? So you could say, we could just rewrite it. If the region is below, maybe that would be better. But it wasn't wrong, it was just weird. Why did I phrase it that way? There you go. If the region is below the axis of rotation. That's better. Now let's get the vertical part. Okay, next page in a second. Just go on this page. And get all the. What's that? Oh yeah, no problem. Vertical axis of revolution. I'm trying to get all the theory down so you can refer to it later. It used to be perfect. for this one, the scenario looks like this. You have some section here, whatever. From A to B. So since if you rotate on the vertical, then I have to slice parallel, which forces a dx question. You will have to solve for x if you're not already. Okay. And this height here. Let me draw it a little bit better. They can fit H and rho. Forgot a piece of text. Some region, who cares? So from here to here, that distance is H. And from the axis to the region, that's rho. Rho x. Okay. Rho is equal to right minus left. Rho is equal to x minus a if the region is to the right of the rotational axis. Going to be equal to a minus x if the region is to the left of the rotational axis. Maybe for this part. This is an example, so you can kind of try to understand this. It makes more sense once we do, in my opinion. So here they're telling us use shell method. To find the volume of the solid formed by revolving the region bounded by y equals to x minus x cubed and the x-axis. From 0 to 1. About the y-axis. So this is telling you where they're rotating. About the y. If I'm rotating on the y, that means my slice has to be what? Or shall it? It has to be parallel to this. So it'll be up or down. Y-axis is vertical, so slice has to be vertical. So I'm gonna go ahead and skip the graphing part and just give it to you. It looks something like this. If we're going to 1, from 1 to 0. So if I'm rotating on the y-axis, right, I have to slice this way. So what is h of x? Because I'm gonna have to be in terms of dx since I'm slicing like this. Because of the rotation that they told me. The rotation dictated how I'm going to slice if I'm using the shell method. If I chose to use this, then I would have to slice perpendicular, but then I would hit two sides, which I would not let me do it. So what is h of x? What's the top minus bottom? Right. Top of the region is this function, right? Minus the bottom. That makes sense. Now rho is a little weird. Rho said it's going to be what? X minus a. If the region is to the right of the rotation. I'm to the right of the rotation, right? It's going to be x minus a, where a is the rotation. So we're rotating on the y equals to 0. So the integral will be x times x minus x cubed dx from 0 to 1. Does that setup make sense? So rho is just some distance x minus whatever the axis is. The height is the top of the region minus the bottom. Is that clear? All right, I'm not going to integrate. I'll move on to the next question. That's cool on this page. All right, let's move on. Use the shell method. To find the solid formed by revolving the region bounded by the graph of x equals 2 e to negative y squared and the y-axis. From 0 to 1. Rotated about the x-axis. Save a little time. Here's the graph. Something, if I close it off here, something like this. Now, that's my section. I'm rotating this way, right? The x-axis. So that means I have to slice parallel to the rotation if I'm using shell. They told me to use shell, so I have to go this way, which means I have dy. So what is h of y? And what is the distance from here to the axis of rotation? Rho. Let's do the easy one first, right? H. The height of the rectangle. What's the right? So let's look at the rules, right? The rule said for height. Sorry. For height, it's just the right minus the left. So the function, the e function minus 0. This is no big deal. Something we've been doing a lot already, right? Now the rho is the one that's kind of strange. This is just, this depends on where the region's at and where the rotation's at. We said that it's going to be y minus the rotation, y minus a, if the region is above. Am I above the rotation? Right, so it's going to be y minus 0. So the formula says volume is equal to 2 pi integral of h of y times rho of y dy. Okay, and the integral will be 0 to 1 because we're doing dy. So this would be 2 pi times the integral of y e negative y squared. So what technique should we use to integrate this?
Substitution.
Yeah, we gotta do substitution. Let u equal negative y squared. Du will be negative 2y, right? dy. There is no negative 2, so get rid of it. So du over negative 2 is equal to y dy. So here we go. 2 pi times the integral of e to the u negative du over 2. Which factors, right? The 2 cancel. This gives me a negative pi e to the u du, which is negative pi e to the u from. Technically, I need to change it back to x before I write the bounds. But these bounds are for x. Do not use it on u, right? So that will give us negative pi e to the negative y squared from 0 to 1. So at that point, I would use a calculator because it's not going to be pretty. It's going to be negative pi e to the negative 1 minus negative pi e to the 0, which would be what? Negative pi e to negative 1 plus pi, which is basically this here. Oops, minus. So, whatever. Anyway, this part, who cares? This is the stuff I already assume you don't have as many questions on. Do you understand how we get the row and the height? That's the new stuff. Right. Row is just some y distance minus the axis. So some y, I don't know how far, because the graph may be weird. I'll let you guys think about dishwasher and shell, and then we'll do some more shell next time. Okay, we'll stop here. I need you guys to, process that for a bit. All right, guys. You guys have any questions about anything in general? Or the homework problem? Number 5, sub 1.
Oh, Mr. John.
Oh, what's up?
Hello. Yeah, it's me, Henak. Oh, are you done? The question?
Yeah, we're gonna do one more homework problem, then we're heading out.
Huh? Oh,
One more question. The other problem on you?
Right now, this is, the area of region, y1
So y1 is equal to
to, x minus 5.
the whole thing cubed?
Yes. And then y2 is equal to x minus 5.
Like this?
Yes.
And they want to know what the,
They want definitely.
the area between. Okay, so let's go ahead and graph one. Let's see here. X minus 5 cubed. X minus 5. That, okay. So let me. So let's.
You guys together.
Okay, so we're integrating two graphs, or this region in between. So it looks like we have to do two different integrals. So we have one integral from 4 to 0. So the top is the red one, bottom is the blue, and then we got to make another integral from 5 to 6, where the blue is the top. So let me set that up, and then I'll switch back to this over here. So integral from 4 to 5. The top is the red, x minus 5, minus the bottom is x minus 5 dx. Then plus the integral from 5 to 6. The top is now the line minus the cube. That makes sense? Is that it?
Okay.
Okay. Okay, so here we go. So this will be So if you cube this guy, it's gonna be. Honestly, I think it'd be better to factor this, because cubing that is annoying. Let me think. That's first cubed. Yeah, I'm trying to find an easy way, because right now it looks annoying. That's this. So let's do this part first. So that's gonna be x squared minus what, 10x, right? Plus 25 times x minus 5 minus x minus 5 dx. I'm going to multiply that again. That will be x cubed minus 10x squared plus 25x minus 5x squared minus 50, plus 50x minus 125 minus x plus 5. So there's my nasty garbage. Okay, so combine everything that we can. Negative 10 minus 15, right? Okay.
So plus 74.
25, oh, 24, said?
Yeah.
That's right.
Minus.
Oh, 74. Got you.
Minus 100.
Yeah. Oh, man. Okay. So then that will be x to the 4 over 4 minus 15x cubed over 3. So 74x squared over 2. Back to 4. Excuse me. So that will be 5 to the 4th over 4 minus 15 times 5 cubed over 3 plus 74 times 5 squared over 2 minus 120 times 5. At this point, I think I would use a calculator. It's getting really gross. And you said it was x minus 5 cubed, right? Just the way I wrote it?
Yeah.
Beginning? Okay. Gonna be a negative +75/4. You still gotta do the 4. So minus everything. Okay.
We can still gotta do the same for the other side, right? For the
Yeah, I think I do
6 and
this
the-
piece.
Is that no?
Yeah, here's that one.
No, Wednesday.
You want in? Let's see here. Wait a minute. Is it 0? Try 0, the volume of the area. The answer, try if it's 0, check if it's 0. On your homework. Let me see. No, you just want to set it up. Where's the 5? That's the first part. They'll be one. All they want is this. They don't want us to solve it, because clearly it's a can't answer. So they just want us to set it up. All right, guys.
So
Yes,
I just got a general question.
I'm sorry.
On the canvas, I just want to ask you a question about the about the canvas. I don't see any assignments. All I see is only the assignments which are due on after December 20. The only assignment I see was the one we have done for September 9. So I don't know.
Yeah, you
if
need to
that's-
go to modules and go to the homework problems. To click modules, you should be able to see the homework sections in Canvas.
Yeah, but it shows me only like it starts on December 20.
You want to share your screen and show me?
How can I show you?
Yeah, the due dates are open till the end right now. I haven't changed the due dates. They're open all semester, I think, most of them. But just go in order. It's supposed to be, you need to have chapter 5 and 6, I think, already done. No, it's just chapter 5, right? So all we've done.
Chapter 5, yeah.
Yeah, as long as you have chapter 5 done, you should be good. Did it work?
I have to. I'll click on the.
Yeah, they just want the setup, but I don't know what happened to our setup.
I'll click on
Okay.